Hello everyone, welcome to my channel. This is Karuna teaching the course Computer Architecture and Organization. Unit 4 contains the following topics, out of which we are concentrating on asynchronous bus in this video. In previous video, we have discussed different data transfer schemes. Those are synchronous bus and asynchronous bus. Asynchronous buses can be used to control the data transfers between the processor and I/O devices. Here we are concentrating on read operation. So the device is input device. Let us see how the data transfer takes place between the master and the slave with the help of asynchronous bus scheme. The data transfer can be controlled by a handshake signals between master and slave. I already told you master is processor and slave is input device because our operation is read operation. Okay, so what is the difference between synchronous bus and asynchronous bus? In case of synchronous bus, same clock cycle is used to transfer the data between processor and input device. Whereas in case of asynchronous bus, common clock in the case of synchronous bus is replaced by two timing control lines. Those are master ready signal and slave ready signal. What's the use of master ready signal? It is asserted by the master to indicate to the slave that it is ready to participate in a data transfer. Coming to the slave ready signal is asserted by the slave in response to the master ready from the master, and it indicates to the master that the slave is ready to participate in a data transfer. Let us see how the data transfer controlled by handshake protocol. Master places the address and command information on the bus. Master ready signal is activated by the processor. It indicates to all devices that it has done. This causes all devices on the bus to decode the address. Now, the selected slave performs the required operation and activates the slave ready line to inform the processor it has done. In case of read operation, process stores the data into its input buffer. Let us see a timing of an input data transfer using the handshake scheme. Okay, so this is the timing diagram for transferring the data between processor and input device to perform read operation. Okay, this bus carrying address bits as well as control bits. Okay, this is master ready signal issued by the processor. This is slave ready signal issued by the input device to perform read operation. This is data bus carries data bits. In this read operation, processor needs to get the data from the input device using this asynchronous bus scheme. Okay, let us see how the data transfer takes place between processor and input device with the help of asynchronous bus. Okay, see, at T0, here this is T0 and this is T1, T2, T3, T4 and T5. Okay, at T0, the master places the address and command information on the address command bus, and all devices on the bus begin to decode this information. At T1, the master sets the master ready line to 1 to inform the I/O device that the address and command information is ready. Okay, here there is a delay between T0 and T1. Okay, so the delay is intended to allow for any skew. Skew may occur on the bus. What is meant by skew? When the two signals simultaneously transmitted from one source and arrive at the destination at different times. This is due to different lines of bus may have different propagation speeds. Okay. Now at T2, the selected slave, here see, at T2, the selected slave having decoded address and command information and performs the required input operation. Means slave places the data on the data bus from its data register. At the same time, it sets the slave ready signal to 1. Period T2 to T1. Here the delay between T2 and T1. This delay depends on the distance between the master and slave, and this delay introduced by the slave circuitry. At T3, the slave ready signal arrives at the master, that indicates the availability of data on the data bus. At the same time, the device interface places the data on the data bus. After some delay, master stropes the data into its input buffer. At the same time, it drops the master ready signal, indicating that it has received the data. So, at T3, master received the data from the data bus sent by the input device. At T4, the master removes the address and command information from the bus. At T5, when the device interface receives 1 to 0 transition of the master ready signal. This is the transition from 1 to 0. It removes the data and slave ready signal from the bus. Okay, data and slave ready signals are removed. This completes the input transfer. Okay, this is how read operation is performed between processor and input device with the help of asynchronous bus. In case of output transfer, means write operation, master places the output data on the data lines by transmitting the address and command information, and then slave receives the data from the data bus. Okay, like this data transfer takes place between processor and I/O interface by controlling the data transfers with the help of handshake signals. Those are master ready and slave ready signals. Thank you. We will meet in next video.